there. Kana akong gilinyahan.
Excuse me, ma'am. Medyo naglibog, ma'am ko. Sak imong kuan, ma'am. Kaya ko kaapas anak kag ari.
Wala, di ko kadungog. Unsa?
Medyo naglibog ko,
Ay,
ma'am. Kung giunsa na nimo pagkuan. Kay karon pa ko kasulod. Tapos wala pa ko kita sa imong video.
I see. Okay, okay. Padyod na ako na-upload ang video. Kinsa to nakasulod last? Okay, Leslie. Jalea. How many amino acids present here?
Asa na, ma'am?
Kani. Kada akong gibagi sa block. This one. Alright. Okay, we have one amino acid. One.
3,
And
ma'am?
then, okay, there are 3 amino acids here. Okay, 3. Now, how many peptide bonds present? If this is your peptide bond, okay, the peptide bond is the bond that links between 2 amino acids. Okay, this is the first amino acid. Now, when the first amino acid, then the second amino acid, imo na silang isagol when you imo na silang i-mix to form one. So, the bond or the linkage that will link them together is what we call the peptide bond. Now, if we have 3 amino acids linked together to form one peptide bond, how many peptide bonds present? There will be
3.
2, ma'am?
2. Only 2. Okay, only 2, Eman? 1 peptide bond. The first peptide bond is the linkage between the first amino acid and then the second amino acid. Then the second peptide bond will be this one. Okay. It's second. Okay, the second peptide bond is the bond that links between the second amino acid and the third amino acids. Okay. Now, here also of these two, okay, of these 2 peptide bonds, okay, of these 2 structure, we have the C double bond O and the N H. Then we have the second one. Which of them is correct? Kay naay wrong anin duha nga pagkasulat sa peptide bond. We have
Second,
First
ma'am?
one,
okay. What to happen to the second? What configuration is that? We have this when we say configuration, okay, the shape, di ba? Sa lipids, we have the shape of the lipids. It does not matter what the amount of fats you take in does not matter. All that matters is the shape, the configuration. Is it trans or cis? Okay, so when we say here, the first one, it is
Cis,
cis or
ma'am?
trans? Cis. Okay,
Ma'am?
cis. Now the second is
Trans, ma'am?
okay, trans configuration. Now, of the 2, the correct one is the trans configuration. Okay, so the peptide bond is in trans configuration. This one is in cis, so ato na siyang balihon H there. Okay. Na to siya. So when we say trans, the O, the oxygen, and the hydrogen are in the opposite sides. Okay, cis, they are on the same plane. Okay, so we have that one again. What's the reaction? What is the reaction that occurs to form a peptide bond, a peptide or polypeptides?
Dehydration, ma'am?
Dehydration or okay, loss of H2O, that's dehydration, or we can also say condensation. Dehydration is equal to condensation. Okay. So that's it. Now again, okay, so it is a chiral. It's chiral. Now it's called alpha, okay? The alpha carbon atom is this one. It's the alpha. Alpha because it's the first carbon next to your carboxyl group. So it's alpha. Now, is it chiral or achiral? Your amino acid is
Chiral, ma'am.
chiral.
Chiral, ma'am.
Okay. Now, it depends. What if your side chain or what if your R group is an H? Like, for example, your protein glycine. Glycine, is it chiral or achiral?
Achiral, ma'am.
Okay, glycine is achiral because the R group in glycine is H. Na duha na ka H diri. Napa H diri. So it's achiral. So out of 20 amino acids, how many amino acids that has chiral centers?
19, ma'am.
Okay, only 19. Kay glycine is part of the 20 amino 20 amino acids. However, glycine is achiral because of the R group or the side chain is just an H. Okay, so last time we talked already about the polar, non-polar, and then the neutral amino acids. Okay, then we also have the isomers, the D and the L isomers. Okay, unsa ga ito tanawon to say that it is a D or L isomer? Okay,
If
if
if naa sa left ang OH,
OH,
ma'am, ang
OH,
L,
Oo, ma'am.
unsa tanawon
H
na.
or
Okay. Tanawan na to is the location of your NH2. Okay, the NH2.
H2. Sorry.
Yes. So the NH2 or the amino group is on the right side. Then it is what isomer?
F,
Right side
D,
siya. D isomer.
D
Okay. If nasa
isomer.
left, we have
Isomer.
L isomer. Okay. So now, okay, we have here. Maglasi mo Sir Ralph.
wala may kabalo, ma'am.
All right. Now let's go to sayang no wala ko na-upload dayon ang video. Okay, we have this one. Ano to diri? We have the acid base properties of amino acids. Okay, so your amino acid. So this is your amino acid. Okay. Now it says that it has an acid and a base property. So okay. So we have that one. So amino acids are charged species, both uh, in solid and in a solution. So if it is a solid, it's still a charged species. And then we of if it's a solution, it's still charged. Uh, the charge there, if we have an acid, okay, so the negative charge, it means that it's acidic group. Okay, acidic group. The acidic group in your amino acid is the carboxylic group, and then the basic group is your NH2. Ay, pangit-kit. Okay, so we have that one, and then also now it says that your amino acid is I know it in a condition called zwitterions. Zwitterions, it's a state of your amino acid wherein uh it means double ion. It means that your positive and negative charge coexist in an amino acid. So if that happens, if duha sila kabuk nag-coexist, the positive and the negative charged species in an amino acid, so it is in deuterion form, deuterion ion form. Okay, so this is the deuterion ion structure. So this is the structure. Again, deuterium means that the positive and the negative charge coexist. Again, why is that it coexist? Why is that? Because your amino acid has an acidic group and then it has also a basic group. Just like your lipids has hydrophilic group and then hydrophobic group. So, amphipathic siya. Duha siya kabuk. The two coexist. Now, here in your proteins, your acidic group and then basic group coexist. Now, if the charge, okay, if an ion, if the charges uh, on an amino acid is has a net charge of 0, then it is in a deuterion form. Deuterion ion. So this is the structure. So the carboxyl group gives up proton to get negative. Okay. So this one, okay, if we have that one, the COOH, okay, your COOH, when we ionize that one, so it will give up a proton. Okay, the proton here is your H plus. So what will happen? It will become COO minus and H plus because it will give up the H here. Now, in the amino groups, it will accept proton. So, mudawat siya og H plus. So, we have here the N NH2. Now, if it accepts proton, so it will react with an OH minus, then it will accept the H here, so it will become NH3 plus. So that's it. Your carboxyl group will give up proton, the H here, and then your amino group will accept a proton. So here, if we react it under a basic condition, so it's basic, so it will accept the H from the OH and then it will become NH3. Now, because of that, because the proton dominates, and we know that protons has positive, okay, it has a positive charge while your electrons has negative charge. Okay, so it because it has ni-accept siya og proton, so munaghan na noon iyang proton, so mudaghan na imuhang plus. That's why we with the sign, the charge there is positive. It means that protons are dominant here. Here in COOH, because it gives up or it loses your H plus, your proton, then what will happen? Your proton is positive. So, pag ihiwala niya ang positive, then your electrons will be dominant. So, that's why it's negative. Okay. Now, we have this one, acid-base properties. So, again, we have, all right, let's go back first. Again, when zwitterion ion, uh, it came from, it's a German term. So it means double ion. It means double ion. So both ions coexist. It both the positive and the negative charge coexist. But again, no net charge because no net charge. When we say net, it's ano no summation. So positive plus negative. That will become like 0. So that's no net charge. So that is deuterium ion, no net charge, and when positive and negative ions coexist. Okay, so we have this one also, the isoelectric point. When we say isoelectric point, it's the point wherein pH at which concentration of deuterium ion is maximum. So it's no net net charge is zero, no net charge. So we have that one. Now if we have example, if we have our proton, if we have our amino acids rather, okay, we have this amino acid, then under acidic solution, when we say acidic solution, in a pH scale, unsa gali ng acidic, pH is, what is pH? Less than zero or no? The pH of, when we say acidic, pH is,
Higher than 0, ma'am.
okay, than 7, okay, higher 0, but less than 7, it is acidic. At 7 pH, at pH 7, that's neutral. Neutral meaning, when you say neutral, both acidic and basic properties can coexist here. So we have also basic here. Greater than 0, that's basic. Now, we have that one. Okay, so under acidic solution, meaning low pH, low yung pH, low of 7. Okay, so we have this one, di ba? 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, it's acidic. The pH, if the pH is between there, that's acidic. And then 8, 9, 10, 11, 12, 13, 14, that's basic. So when we say low pH, it means that here, it's here. It's okay. Because amino acids in a solution exist in 3 different species. Okay, so we have that one. Now, it can be zwitterion. Again, when we say zwitterion, no net charge. Positive and negative charges coexist. Then we have the positive ion and the negative ion. Then equilibrium shifts with change in pH. So there are three. Again, there are three. If we have this one, this is under acidic solution. When we say acidic solution, the NH3 is protonated. The NH2, di ba? NH2 raman ang tani siya class. Then it becomes NH3. Okay, we have there. NH2. Look at this one. It's NH2. Now, if it's under acidic solution, ibutang nimo siya sa suka. Example, your protein, suka, acidic solution. Then, your amino group will be protonated. So, mahimo siyang NH3 plus. And then, okay, that's acidic solution. But under neutral solution, when we say neutral at pH 7, it's the zwitterion. Okay, it is in zwitterion, meaning that the NH3 is protonated and then the COOH, your carboxylic group, loses the proton. So it carries the negative charge. So positive, negative, that's 0. So it's in zwitterion. Now here, what is the charge, the net charge here in acidic solution? It's,
Positive, ma'am.
okay, it's positive 1. Positive 1. Only 1 naman siya. Here, it's 0. Now, what about under basic solution? What will happen? Okay. Under basic solutions, your uh, your carboxylic group loses a proton. it loses a proton because here in under neutral solution it loses a proton, and then also your amino group is protonated, accepts proton, so duha sila kabuok. Then here only the COH has reacted. Okay, here in the acidic solution, only the amino group reacted. That's why name mo siyang NH3 plus. The under basic solution, your COOH only kanira nga group ang react. Then it loses proton, so that's why it became negative. Now what's the charge here? Net charge.
-1, ma'am.
Okay, negative 1. So that's it. So when we say isoelectric point, it's the pH at which at which the deuterium ion exists. So here, the Pi here is 7.0. Now, let's matutag next example. So we okay. Now let's go. Let's maanita dire. Okay, that's it, ha. Don't forget that one. Now, okay, we have this one also. Okay, last one. So at pH values lower than Pi, the carboxylate end of the deuterium picks up a proton from solution. The amino acid acquires a positive charge. Okay, this one. Okay. It's under, we know that this one is deuterium, not net charge. Then this one is under what? What solution? Under basic or acidic solution? Merely.
Acidic, ma'am.
Okay, it's under acidic solution. Now, what about here?
Basic solution.
Okay, under basic solution. Okay, that one. Right. Now, if we have this one, okay, so for the drill, for each, okay, for each amino acid, we have alanine. Okay, your alanine has pK1 equals 2.19 and then pK2 9.67. All right, now let's draw that one. Okay, so what's the structure of your alanine? Your alanine, some alanine. Okay, so here we will do because again, amino acids can exist in 3 different phases. So we will draw under basic condition, under acidic, or under neutral condition. Okay, your alanine, the side chain there is, we have your amino acid. Hoy. Your alanine is NH2, then C, then COOH, then we have the H. Your R group there is CH3. So this is your alanine. Okay. Now it says that the isoelectric point or the pK of alanine is 2.19 pK1. So that is this one. This is 2.19. And this one is 9.67. Okay, so let's draw that one. Now we have 2.19. Then we have here 9.67. So, national. Then, below, okay, before 2.19, so below 2.19, that is acidic, no? It's still acidic condition. Now, what will happen? Let's draw the structure of your alanine under acidic solution. So, what will happen? C, H, then what will happen? So the amino group will be protonated. So that one. Okay. Then after 2.19 or in between 2.19 and 9.67, your alanine, what will happen to your alanine?
Neutral, ma'am.
Okay. You just draw this one, the NH3, it's still protonated here. And then what will happen to COOH? It will,
Three negative,
Negative,
ma'am.
ma'am.
okay, it will lose proton. All right, so it will become negative. Then, so under basic condition or after 9.67, mga 9.68 up to 14, your alanine will become, what's the structure of your alanine?
Basic,
Negative na,
ma'am.
ma'am.
Negative.
Okay, negative ang COO. Then what happened to the amino group?
Dili na siya protonated.
Uh,
Okay, it
it,
means that your NH3, okay,
Nag-
your NH3 loses proton. Okay, then we have CH3 and then we have an H here. Okay, so now let's go to the charges. We know, okay, so what's the net charge here under acidic condition?
positive 1, ma'am.
Positive one.
Okay, that's positive 1. Yes, positive 1. Then here, what's the net charge?
0, ma'am.
Positive
Here,
plus negative, that's a 0. Okay, then here, what's the net charge?
negative 1.
Negative
Negative
1.
Negative
1.
1, ma'am.
Now, in these three structures, which is in deuterium ion?
The neutral, ma'am. The zero charge.
As in a structure, this one. So the one with zero net charge is your deuterium ion. Okay, so that's it. Now, what will be the PI, the isoelectric point? Isoelectric point is that it's the average point wherein the where it's the average point wherein you can find the structure which is in deuterium ion. So as a shadapit, we have two,
0, ma'am.
it's in between 2.19 and then
And
9.67.
9.
Okay, we add that one because it's an average. So divide by 2.
2.
Okay, so what pila man na siya class? Pila siya? Calcio. Okay. 2.19 plus 9.67, 11.86 divided by 2, that is equal to
5.93.
okay,
5.93.
5.93. So the PI, the isoelectric point of your alanine, okay, it's the point in the pH at pH 5.93, your alanine is in deuterium ion, meaning the positive and the negative charge coexist. So at pH what? pH what pH gali
5.
mag-exist ang okay, 5.93. Okay. So that's it, ha? Because we make this one class because of the acid base property of your amino acid. Now, if there's acid neutral base. So, meaning that your amino acid are different species in different condition, in different pH. If we have a low pH or acidic, so your amino acid has a different structure, like this one. what happens here is your amino group is protonated. Now, when it is in neutral, your amino group and then your carboxylic group are both charged. So it's zero, the net charge. Then under acidic or under basic solution, the NH2 is not protonated. Then your carboxylic group loses electrons. Okay. It loses nga naman class, nga naman ang COH because COOH is is acidic. Surely if under ibutang nimo siya sa basic nga solution, if example sa baking soda, if ibutang nimo siya dito, the one that react to the baking soda na basic is your acidic group. So so ang imong mahilabtan there is your COOH. Now, if under acidic solution, okay, under acidic solution, ibutan mo sa susuka, ang mo react there is your basic group. Okay, di ba? Acid, ano siya, di siya pareha sa katong ato sa lipids is ang hydrophobic, mo react kapag sa hydrophobic, then ang hydrophilic mo react sa hydrophilic. Now, in terms of acid and base, ang mo react sa acid is your base, and your mo react sa imong base is your acidic group. Okay, ha? All right. Now, for another example, if we have, okay. Okay, so draw the structure of amino acid as the pH of the solution changes from highly acidic to strongly basic. Okay, so letter A, gidraw na to siya. We're done with that drawing. Then, which form of amino acid is present at isoelectric point? Okay, letter B. What's the answer of letter B? Which form of amino acid is at isoelectric point? The answer is
5.93, ma'am.
which form? When you say form, structure.
One, ma'am, neutral.
Okay, kaning nasa
Neutral, ma'am.
tunga. Alright, kaning nasa tunga no nga form, kaning nga structure. Okay, now calculate, letter C, calculate the isoelectric point. The average of the two pKa's bracketing isoelectric structure. Okay, so it's the average kung asa dapita imuhang isoelectric structure. Asa siya naglay. Okay, Pi is equal to 2.19. Naman siya sa center, no? Tunga siya. 2.19 plus 9.67 divided by 2. Pi is 5.93. Okay, let's answer number 2. Ay, letter B. Structure 1. Structure 2. Okay, question. Now, we have number 2. Let's go. Asparagine. Hala, tulo ka bo class. Asparagine 2.09, 9.82, and 3.86. Okay. Let's go here. So first thing to do is, what's the structure of asparagine? Asparagine, 28 no? Asparagine. Okay. Here. This is your asparagine. So it is neutral. Wait sa class. Okay, NH2 alanine. Okay, the structure of your asparagine is, we have that one. We have, okay, your amino acid, NH2, COOH. Then we have your H group here, and then the R group is CH2, CH2, C double bond O, and then we have NH2. Okay, ako siyang gibalik class ha. Ako siyang gianap po form. Now we have that one. Okay, it says that your PK1, balik ta. Okay. PK1 is 2.09. This 2.09. Now, class, ang 1 gali PK1, that's the ano, PI, that's the pH of your carboxylic group. Then the second, the PK2, that's for your amino group, 9.82. Then, unsa maning na 3? 3.86. Asa man ni siya? It's for your R group. So this one, this is 3.86. Okay. Now, letter A. Let's draw the structure of amino acids as the pH of the solution. Okay, so let's draw that one. We have a 2.09. 2.09. Then next is okay. We have that one. Now under acidic solution, the structure will become, what will happen? Your amino group will be okay, protonated. Then the H, then COOH, and then you have the R group. CH2, C double bond O, and then we have NH2. Okay, because it's under. Now, after 2.09, what will happen?
Zwitterion.
Zwitterion na dayon?
Neutral, ma'am.
Nawala siya.
Nalis.
Wala. Asa na si ma'am? Nawala na.
Gamay ra banday kayo ta.
Nangalag pang uban.
Nanagot sa kalkalat.
Kalag-kalag pag di aruno.
Wala din ni holiday ning kuan, online class.
Uli. Ang uban biya kay 7 pa silang balik. Bomba.
Naol.
Asa naman si ma'am?
Iyan lang. Sana.
Lami pa kay magkuan no magharay-haray baka naman tong murag wala klase sana.
Sana all.
Julia, sana all kay ka. Sige ka galaag na all.
Ang uban gapadagat na.
Lagi. Siksik kay sa ta.
Naan ka saan?
Di na guro to mabalik si ma'am. Pero record mo niya.
Basta yung brand out ilang mamba. Oh. Chat daw mo sa GC.
Hello? Earth. Nawala ko. Nawala currently. Good. Wait. Okay. Shin. Saan na to? Okay. Hello, makita akong screen?
Yes, ma'am.
Okay. All right. Now let's go back. Okay. So we have this one. Now after 2.09, what will happen? It will become, so let's just copy, the NH3 is protonated, then the C, then what will happen to CO?
Mag-lose of protein.
Okay, it will
Electrolyte.
lose proton. Okay, then we have
Recognize na.
CH2, C double bond O, and H2. No? Then after 3.86, what will happen? So we have, what will happen?
Only the C.
May mo siyang basic structure, ma'am. NH2.
Okay, so it's after 3.86, what will happen since it is it's still under what? What solution?
Basic, ma'am.
Okay,
Acidic,
it's
ma'am.
still acidic solution. So we have here, okay, mukha mo siyang ano, kay acidic man siya, what will react? Oh, it's under neutral. NH2 of the C, then COO. Okay, so it will go back. So in each, your amino acid will, the N group will lose proton. Then we have CH2, C double bond O, then NH2. Now here at 9.82, after 9.82, what will happen is to, kanina dayon ang react in 9.82. So the NH2 will be protonated. The COO minus, and then we have here CH2C. So double bond O. Now, your after 9.82, ang NH2 na pod ang imuhang mo protonate. This one. Okay, katong sa side chain. So this will become NH, okay, NH3 plus. Okay. So now here, what will be the charge?
Positive, ma'am.
Okay,
Positive
charge
1,
is
ma'am.
positive 1. What about here?
0, ma'am.
0.
0. Then, what about NH2 after 3.86? The charge is
Negative 1.
negative 1. Okay, but here it's 9.82. What's the charge here?
Negative 1 Japan, ma'am.
Ma'am.
Okay, the charge will be positive, positive. Hindi po ba 0? Diri charge class zero positive ma zero siya no. Ato ha. Deuterium. Because it's negative under acidic. It's under basic. 9.82. Siya ma-react diri. 2. Tipod no kay basic man ni siya under basic condition, then the NH3 is basic so it will not react. Libog ko. No? So the Zwitterion here, mo ni siya ang Zwitterion class. It's the PI here is dire 2 2.09 plus 3.86 over 2. Pila ni siya PI? PI is Zwitterion of asparagine. So PI is
2.9 ma'am or 3.
37 ma.
2 po pila? 2.30
9, ma'am.
9 ma'am.
39. That's the PI. And there.
2.9 ra ma'am.
Murag di man apil ang
2.9.
9.6, ma'am.
Like kani 2.9. Pero nakuan ko. Something wrong. NH3. PK. There's something wrong ani class. Okay, so ano na lang B? This one. Number 2, number 3. Okay, that's for your assignment. Okay. Okay. Then I'll discuss number 2 next. Okay. Or mag-video ko ani.
Ma'am.
Sa'yo. Then lysine. Okay. So pwede na inani. Number 2 and number 3, that's for your assignment. Okay ha? Find A, B, and C. Find A, B, and C. And H2 man. Okay. Magbuhat ko dito sa atong kuan dito kuan submission box. Dito sa atong chi class. Okay ha, number 2 and number 3. Okay, let's move
Ma'am,
on. Okay, then next meeting I will discuss number 2. Okay. So let's move on. NH3. Neutral magud ang kuan asparagine. Yung R. Reaction. Okay. Now, sige. Alright, so we have this one. Let's go to peptides. Again, what is peptide? Okay. Now, so before that, okay, before we proceed na lang ha, because naglisod to diri because neutral siya no, neutral. Now, what if I will give you this this structure, the structure, okay, this one. H2, then N, then we have the H here na lang be. Then you have your CH2, that's 4, 3, 3 rather. And then you have your NH2, it's plus. What structure is that? Okay, we have that one. Okay, this is your example ha. Pangita na to siya isoelectric point. So that is your four NH3 plus. NH3 plus. This is your lysine. Okay. NH4. CH2, CH2. Okay, so this is your lysine. Now, it says here your lysine has 2.18. So, pK of 2.18. Then, we'll have your 8.95. Then, we have the side chain. For the side chain, the pH of your side chain is 10.5. 10.5 because this one, your lysine is basic because of the presence of your NH3 plus. So it's basic. So 10.5. Now, okay, if we are going, so how many, ano man ni siya class? How many structures kung atong mabuhatan ni? We have
Ma'am?
pila 4. Okay, we have 4. So 2.18, then 8.95, then we have after 10.5. Okay, so before 2.18, what will be the structure?
In H.
NH3 plus. Okay, so it will be protonated. Then we have CH2 for NH3 plus. Then we have COOH. Then, okay, what's the charge here?
Positive, ma'am. Positive 1.
Positive 1. We have positive also here in NH3.
Positive 2.
Positive 2, ma'am. Positive 2, ma'am.
Okay. Now, for after 2.18, what will happen? Okay. So, after 2.18, what will happen is NH3, okay, your COOO, the carboxyl group will react. We have NH3 plus, then we have the plus there, then COO minus. Then after, okay, the charge here will be
Positive 1, ma'am.
okay. Now, the second, okay, after 8.95, what will happen is after 8.95, your NH3 will lose proton. Okay, so will become COO minus. And then we'll have your CH2 and H3 plus. Okay. So after losing after losing a proton in your in your N group, after 10.5, so kanina po dayon imong side chain ang mulus og proton. So we have that one. The same ang imong carboxyl group. Then we have the CH2 4, then NH2 and H2. Then we have another NH2. Okay, so here, what will be the charge here?
Zero, ma'am.
Zero, ma'am.
0. Okay. Now, in here, what will be the charge?
Negative 1.
Negative 1. Okay, so, all right. Inyong lang ikuan class is before, okay, under acidic solution, 30. We have this one, NH2 or your N will be protonated, so it will become positive. And then under next condition, your carboxyl group will lose a proton. Then after that one, after here, your NH3 will lose a proton, so it will become NH2. Then after that, pagka next is kanina po dayon inyuhang this side chain. Okay, so ang mag-lose og proton. Now, so what structure is in Zwitterian ion form? It's
Chiral,
structure.
ma'am.
Okay, structure 1, letter A, B, or C, or D?
C,
Structure.
ma'am.
Okay,
C, ma'am.
structure C. Now, what will be the PI there?
Between 8.5 and 10.5, ma'am.
Okay, between. So, okay, the PI is KPI is what? 8.95 plus 10.5. Pila man a class? Divided by 2.
9.7. 9.7, ma'am.
7, 3. Okay, round up. All right, so this is your PI. Now, okay, so this is when you have your side chain, when your R group is basic, di ba? Basic man siya, no? Polar basic amino group. Now, katong ganina is we have the side chain is neutral. Now, that will be your assignment. So, you form or you draw the 4 different structures at different pH niya. Like this one. So it's not hard for if you have a polar basic or you have acidic na siya charge ang imong R group. Now, what will happen if no charge like this one, neutral? Now, you look for that. Okay, then I will discuss that next meeting also. So that will be your assignment. Okay, ha? Okay ra, class?
Ma'am, kana sa yes, ma'am. Ma'am, kana sa deadline.
Okay, kana sa deadline? Basin ano?
Friday, ma'am.
Thursday. Okay, Friday. O sige, Friday.
Monday.
Yeah,
Okay.
ma'am.
Now, alright. Ay, lysine. Okay, so lysine. Humanang lysine class. Okay,
Yes, ma'am.
lysine. Okay, I'll mag-change ko ni tyrosine. Tyrosine. Okay, pero ako rin siya butang dadto ha. Now you look for number 2 because it's neutral ang imo side chain. Okay, so let's go. We have this one, the peptides, nature of peptide bond. Again, the bond that occurs when that links amino acids is what we call the peptide bond. Again, it's in S. It's in trans configuration. So it's in different plain imuhang O and then the H. We have this one. Under proper conditions, amino acids can bond together to produce unbranched chain of amino acids. Okay, that's it. Reaction between group amino of another amino acid. So the length of amino acid chain can vary from few amino acids to hundreds of amino acids. Again, your protein is made up of 40 amino acids. At least 40 amino acids. Now, if less than 40, then that can't be called a protein. It can just be called a peptide lang siya, polypeptide, but it's not a protein. Because for it to become a protein, it has to be equal to or greater than 40. Such a chain of covalently linked amino acids is called a peptide. Okay, so it's a peptide bond. Then it also forms an amide bond. Let's go back to ganina. Okay, this one is your peptide bond. Now it's an amide because of your N. Okay, amide bond or peptide bond. Okay. Wow. Wait sa class ha. Balik ko. Ko sa charger. Okay. So, okay, now the covalent bonds between amino acid and a peptide are called peptide bonds or amide. Okay. So, we have this one. Okay. Now, as you can see here, nasa drawing here. Okay. So, this one is your peptide bonds. Okay, this one is the peptide bonds. Okay. Okay, by convention, the structure of peptides is represented beginning with amino acid whose amino group is N-terminal end. Okay, so this is your N-terminal, and then we have your C-terminal or C-terminus or N-terminus. So N because it's for nitrogen, and then we have the C-terminal for COO minus. Okay, so amino acids are added to peptide by forming peptide bonds with the C-terminal acids. Okay, so we have this one. we have NH3. It's a free NH3, and then we have the COO minus. It's the free COO. Okay, so here the H. All right. Okay. So as we can see here, how many amino acids present here in this one? Here, how many amino acids present?
Ooh.
We have,
Tulo, ma'am.
okay, one, and then two, then we have three. Now, okay, the first amino acid is what we call,
Alanine.
okay,
Alanine, ma'am.
alanine. Then the second one is phenylalanine. Okay, that's amino acid also. And then we have a serine. Okay. So when you draw a structure, it should when you draw a polypeptide, this one like this, the N terminal end must be ano free must be free in H3, meaning it should have a charge of positive NH3 plus. Then here, then the C terminal should be negative or COO minus, because di ba amino acid is like this one, NH2, then COOH, then we have the R, and then the H. Now, when you draw that one in a polypeptide, the N terminal must have free proton. So, pwede siya muhawa. Pwede siya. Okay, must have positive charge, and then we have this one must be negative, just like this one. All right. Now, also, okay, they are in trans configuration. Okay, trans configuration. The double bond O and the H are on different plane. So CN bond has a partial double bond character. Okay, so that's it. Now we have this one, a peptide terminal. C terminal and acid residue keeps it full amino acid name. Okay, now how do we name your amino acids? Now if we okay, if we have this one, okay, let's go back here, you said earlier that there are 3 amino acids present. Now, this is a polypeptide, a tripeptide to be specific, because there are 3 amino acids. Now, it says that the last, or in the C terminal end, the C terminal amino acid residue keeps its full amino acid name. So what's the C terminal amino acid? It's unsa ang pinaka-last nga amino acid class?
Serine.
Serene, ma'am.
We have the serine. Now, okay, that's the last name. Okay, then for the N terminal, then for the backbone, we will have, okay, alanine, then we will end it with YL. So we have alanil. Then what will happen to phenylalanine? What will be the name?
Phenylalanil.
Okay,
Phenylalanine.
phenylalanil. Pheny, phenyla,
Phenyl.
pheny, la,
Phenylalanine.
nil, serine.
Phenyl.
Okay, so only the C terminal end will have the complete name.
Anil.
Now the end terminal end and then the backbone will have the YL end. Okay, like this one, alanil phenylalanil serine. So this tripeptide, what's the name of this tripeptide? Okay, unsa ngalan ni nga tripeptide class? The name is
Asa man, ma'am?
kani nga tripeptide. What's the name?
Alanil phenylalanil serine, ma'am.
Okay, that's good. So that's how you name your peptides. Okay. All right. Now, if we have this one, okay, if we have this peptide, okay, how many amino acids present?
2, ma'am.
Two.
3.
Two.
3, ma'am.
Okay, we have three. One, two. Okay, we have three. Now, what's the name? What's the first amino acid? Yung side chain CH2SH. Is it polar, non-polar?
Non-polar.
Polar, ma'am.
Okay.
Then
All
polar.
right, so it's polar neutral. So what's the name? It's
Site.
Cysteine.
Cysteine.
okay,
Cysteine.
cysteine. All right, cysteine. Sige. Then what's the second amino acid? CH3. Ano ni CH3? Alanine? CH3 or iyang po iyang R group. And then this one, H iyang R group. Okay, pangitaan na to na. If this one is it polar, the second amino acid,
Yes, ma'am.
is it
Polar.
polar or non-polar?
Polar, ma'am.
Non-polar.
Polar.
Polar, ma'am.
Polar to, ma'am.
Polar CH3?
Non-polar, ma'am. Dili,
Okay,
ma'am.
non-polar. All right, non-polar. CH3. So what's the name?
Valine, ma'am.
Alanine.
Oh, alanine.
Alanine. Okay, CH3 or yung R. Then that's the third one is we have
Glycine, ma'am.
Glycine.
glycine and alanine. Okay. All right.
Glycine.
Okay. So what will be the name? Okay, the first one is
Phenyl.
okay, cystenyl.
Alanil.
Laniel dayon.
The third one,
Glycine.
glycine. Okay, so that's how you name your peptide. Okay. Now, if we write that one, okay, if ano lang siya, abbreviation, so we will write the first three letters. The first three letters of each amino acids. So we have here. So the first amino is cis. Then the second is alanil, no?
Yes, ma'am.
Ala.
Ala.
Then gly.
Gly.
Okay.
Alaglay.
Okay, so cis alagly, meaning the sequence is the cysteine, alanine, and then the glycine. Now, if I write cytine, glycine, and then alanine. Are they the same class?
No, ma'am. No, ma'am.
Okay. Huh?
Dili ma'am
No.
dili.
Lahi
Okay.
siya, ma'am.
So, all right. Now, what unsa tawag na to na nila? They are okay, nauna ang gly, nauna ang nasunod ang ala. They are isomers. Okay, so they are isomers. Now, isomers, they have the same number of atoms, the same amino acids present. However, the sequence is different. Now, just like the L and the D configure, the L and the D isomer, they look the same. However, the shape is different. Meaning, if the shape is different, just like this, the sequence is different, it will also have a different biochemical function. Okay. So, for your assignment, okay, you draw. Okay. All right. Now, wait. This is the assignment. But here, okay, how do you name this peptide? Okay, how do you name that peptide?
Sin.
We have
Glycine,
Sin, ma'am.
Sin.
Hagly,
Sin, ma'am.
sin,
Glycine. Sil, ma'am.
Glycinate.
glycel,
glycil,
tyril,
Ty.
Chiral.
tyryl, really, tyryl. Sige, tanaw na to, tyryl ba siya? TYR. What's TYR? Okay. Okay, this one. TYR is
Tyrosine, ma'am.
tyrosine.
TYR.
So, tyro,
Tyrosil. Ay,
tyrosyl. The next one is
Leucil.
leucyl,
valid,
Valine.
valine. Okay, valine.
Valine.
valid,
Valine. Okay, so this
Valine.
one. So that's the name of your peptide. Now, if I ask you to draw this peptide, can you draw? Makadraw ra
Murag ko.
class? Okay, let's start with smaller one na lang. If we have the ser and the gly. Okay, so what's the name?
Cereal o glycine.
Serial.
glycil,
Glycine.
Now let's draw the structure of serial glycol. Serine. Okay, serine is yung R group is OH and CH2. So what will happen?
In
C, then we have C, double bond O, then we have the OH. Then we have your R group. What's the R group of serine? O CH2 OH. Then what will, di ba, NH2 manino? Now, what about the glycine? If we have the glycine, H. Glycine is the simplest amino acid because unsa ang side chain? Unsa ang side chain class sa glycine? This is your glycine. The R group is just an R, just an H. Okay, so it's very simple. Okay, now if we form that into a peptide bond, so what will happen? It will become, so the OH and the H here will lose. So for that will form again N C. Again, pag peptide bond na siya class, it should have NH. The N terminal is positive. Okay, so NH3. Then we have the R, CH2OH. Then we have the C double bond O. Then we formed it with our nitrogen. So come on, and siya class O. The bond there. The bond is N. Then since it's trans configuration, that one, then you write the K, H. C double bond O. Then we have the O minus. Okay, so this is your dipeptide cereal glycine. Now, if I ask you to write the structure of this glycyl tyrosyl usyl valine, maka-write? Kaya? Okay. So, that will be your assignment also. Write the structure. Isulat yun ninyo, class.
Okay, ma'am.
Of this one. Okay, glycyl, tyrosyl, usyl, valine. Okay, i-add raman ninyo class, isumpay-sumpay raman ninyo na amino acid plus amino acid plus amino acid na pod plus amino acid. Then, remember that it's the bond there is a peptide. C, it's an amide double bond O, then NH. Then, take note lang po that N terminal is NH3 plus. Then, the C terminal is COO minus. So, in another class. Okay. So, duhanan yung assignment. Okay. Now, let's move here. So, we have this one, isomeric peptides. Okay. Isomeric peptides. Again, like this one. Okay. What's the dipeptide name? The name is
Alanine,
alanyl.
glycine,
Alanyl glycine. The second one.
glycine and
Glycyl
glycyl and
Alanine.
okay.
alanine.
Glycyl alanine. Now, we have that one. So, they are, again, you said that they are different. Okay. They are different structures. Yes, they are different. However, they have the same molecule, the same number of carbon, the same number of oxygen, the same number of hydrogen. Ipagali ninyo class parihara. What's the difference is that the sequence, alanine comes first and then the glycine comes the second. Here, glycine comes first and then alanine the second. Now, if they are, that's why they are called isomers. Same number of atoms. however, different structure. Now, if they have different structure, it means that they have different responses and function in our body also. So they have the same amino acid, alanine and glycine, but different order, different sequence. Now, that is because just like your just like your monosaccharides, just like your amino acids, they have the D and the L isomers. Okay. Now here, the isomeric peptides, when we count, if we have two, if we have two, if we have two amino acids, then there will be 2 factorial of isomers. What's this one? If we have two amino acids, what's 2 factorial? 2 factorial, that is equal to 2 times 1. So there will be, okay, there will be 2 isomers. Okay, this one, first isomer, then the second isomer. Now, if we have this one, 2, 3, 4. If we have 4 amino acids, how many isomers?
4 factorial. So,
Okay, 4 factorial. That will be 4 times 3 times 2 times 1. Pila? 12
12,
times 24. Meaning there
24,
will be 24. Okay, there will be 24 isomers of glycyl, tyrosyl, usyl, valine. Now, if we have, ano, if, okay, glycine. Okay, 2. How many, ano man, isomers? 2 factorial only. Now, if we have 3. Okay, if we have 3 amino acids, how many isomers?
ma'am.
3.
6, ma'am.
Okay, when we solve factorial calc, pag wala mo i-calcu, paubos na siya always. We have 3 times 2 times 1. If we have 6 if
6.
6 amino acids, how many isomers?
30, 120,
6 times 5, 30 times 4. 30 times 4, pila man na class? 120.
50, ma'am.
Times 3,
10,
360. Times 2, 720. So there,
20,
taas
ma'am.
kayo. Yes, there will be 720 isomers. Okay, so that's isomers. The number of isomeric peptides possible increases rapidly as the length of peptide chain increases. Okay. So many. All right. Now we have that one. Write the structure of tetrapeptide. Okay. At the isoelectric point, calculate the pi also. Okay. So we have this one. Okay, let's not write na. Let's not answer this one na lang. Okay, so it's a tetrapeptide. Okay. So we have this one. The biochemically important small peptides. We have, okay. We have for hormone, okay, hormone action. Then we have neurotransmitters, antioxidants. And then we have artificial sweeteners. Okay, this is a small peptide. Okay, a small peptide has how many amino acids? Kung small peptide lang siya. It
2, ma'am.
has
2, ma'am.
1 or 2.
2.
okay, uh, small peptides. Okay, kanang mga gagmay, mga less than 10. Okay, this one. Okay, we have this one best known peptide hormone. Okay, we have oxytocin. Okay, when we say oxytocin, di ba, mga happy hormones. Okay. So, oxytocin and vasopressin, so they are small peptides produced by pituitary gland. Okay, now notice class this one. What's the difference of oxytocin and vasopressin? Okay, what's the difference of oxytocin and vasopressin? Okay, class, they have the same tanawa, same structure, same drawing. Okay, now what's the difference is that in amino acid 3 and amino acid 8. Now, if we have an oxytocin, the amino acid 3 is what? Amino acid is isoleucine. Isoleucine. And in amino acid 8, what
Leucine.
is present is leucine. Now, however, if we have a vasopressin, the
Pin-
amino acid in amino acid 3 is
Pininilanin, ma'am.
phenylalanine. And then we have in the amino acid 8 is
Um,
Arginine.
okay, arginine. Okay, so now notice that they almost have the same structure, just a slight difference in the amino acid will cause will cause a different function. Now your oxytocin or your happy hormone, it also for nursing mother, it also regulates milk para sa mga katong mga nagpatutoy, lactating. And then your vasopressin is regulates excretion of water in the kidneys. So just a slight change of your amino acid will cause a different function na. Your layo ra kay sa function, oxytocin, basta leucine, and then isoleucine. It's for nursing mother. It stimulates milk para na matutoy si baby. Then if ilisan lang siya og gamay na phenylalanine o arginine, then that protein, that peptide will have a function on the kidneys na dayon. Okay. Now, your amino acid cysteine is very unique. It's unique because it has it has sulfur. It's the amino acid that has sulfur, the cysteine, and it makes it unique because the two sulfur can form disulfide bond. Disulfide bonds. This one. Okay. So disulfide bonds. Then that's it. So cysteine is the only amino acid that has sulfur. Okay, then we have almost hapit na ta. Okay, we have the small peptide neurotransmitters. We have enkephalines, the pentapeptide neurotransmitter produced by the brain and bind receptors within the brain. So it helps reduce pain. So this one, it helps reduce pain. Okay, so we have metenkephaline. Okay, so what's the difference of metenkephaline and leuenkephaline? The difference is
structure,
what's the,
ma'am.
what's the difference of the two? Look at the sequence, amino acid sequence. Same. Only difference is
og Leo.
Okay, met is ano, methionine. And then we have the leucine. Okay, you have to be familiar with the amino acids class. 20 raman sad sila kabuok. Okay. So it help reduces pain. So kanang ato mga ano pain relievers, mga drugs it has enkephalins. Enkephalins. Okay. Now we have this one. Okay, use your aspartame. Remember your aspartame, it's an artificial sweetener. Okay, so aspartame, the other name is equal or your NutraSweet. Your NutraSweet. Banha kayo. Okay, so this one, aspartame, okay, it has a dipeptide. It's a dipeptide. Your phenylalanine and then your aspartame or aspartic acid. So notice that class, your artificial sweetener has disadvantages. Okay, I told this already that in a study using the rat, okay, the rat that has been dosed with aspartame with your artificial sweeteners, na siya ano, ano, it stimulates tumors inside the body. Kita nawa nagdako siya. So then we have the proteins. Now proteins, there are four types of proteins. We have the primary, secondary, and then we have the tertiary. Primary structure is the order in which amino acids are linked together in a protein by peptide bonds. Okay. Now, this primary structure, when we say primary structure, it's just a straight chain. Okay, it's just a straight chain. Now, example here, we have your primary structure. Okay, this is your, this is your normal red blood cells. Normal red blood cells. Okay, as you can see, it has this peptide bonds. Okay, now can you differentiate the polypeptide of your normal hemoglobin and then your sickle cell hemoglobin? If you have your normal, you have this sequence. You have the valine, histidine, leucine, tryptophan, then proline, glutamic acid, lysine, serine, alanine. Now, what about your sickle cell? What's the difference? The only difference is,
Yung balin, ma'am, o kanang
okay, that's
Folic
one.
acid.
All right, so that's the difference. Now, notice that just a slight difference of your amino acid can have a different function. This is your normal red blood cell, normal hemoglobin, so it transports oxygen to the body. Now, if the change of glutamic acid with valine, then it will become a sickle cell having this shape. Okay, the red blood cells are circle. Now, if sickle cell, you have this shape, isarac amino acid ang change, then the function also has changed from a normal hemoglobin that transports oxygen. It becomes it can cause clogs in blood vessels. So this one. So magklag na siya dito sa imong blood vessel. So what's ano lang here is that the sequence is very important. Okay. Now, we have also here. Okay, let's go to the next page. Almost hapit na ta class. Okay, we have the sequencing of protein. Okay. So we have the hydrolysis, the identification of the products of hydrolysis, fitting the pieces together in a jigsaw puzzle. Okay, acid hydrolysis. When we say acid hydrolysis, it is in the presence of acids, then at higher temperature. So it destroys tryptophan, TRP. Okay, TRP. Now, if we have an alkaline hydrolysis, it's in the presence of a strong basic solution. Now, it does not damage TRP. However, it damages a lot of more amino acids. Then we have also, okay, we have also the enzymatic hydrolysis. It's the use of proteases or peptidases. So enzymatic hydrolysis, again, enzymes helps break or cleaves those bondings in order for it to convert into a smaller one. If a pentapeptide, then using a proteases, we have, okay, example of enzymatic hydrolysis. We have exopeptidases. It cleaves external peptide bonds. Then like aminopeptidase. So iyang gina-cleave their class is just the N-terminal end. Okay. The N-terminal end. So katong mga exo meaning external lang. So i-gina-cleave niya is this one also and this one. Now the enzyme that cleaves your N-terminal end is what we call aminopeptidase. Now the one that cleaves your carboxyl end is we have carboxypeptidase. Both are exopeptidases. We have also endopeptidases. Now endopeptidases cleaves internal peptide bonds. Okay, who cleaves this bonds here? They it's the endopeptidases. So i-break niya class ba? I-break. So the trypsin cleaves peptide bonds at the carboxyl end of two strongly basic. So we have the arginine and the lysine gina-cleave. Okay, if we have the lysine or arginine here, then trypsin cleaves it. Then we have chymotrypsin. Yang gina-cleave is this one. Tyrosine, tryptophan, leucine, and phenylalanine. Then, for the pepsin, it cleaves phenylalanine, tyrosine, tryptophan, and isoleucine. Okay, so we have the enzymatic hydrolysis, exopeptidases, and the endopeptidases. They cleaves the amino acids. Okay, then we have chemical methods of determining the N-terminal end and the C-terminal end. So we have this one, Edmonds method, phenyl isothiocyanate. S- mm, oh, we have that one. So it combines with N-terminal amino acid, okay, to yield phenyl phenylthiohydantoin compound or PTH amino acids. Or also we have for the N terminal end, we have 2,4-dinitrophlorobenzene or the Sanger's method. And then for the C terminal end is we have the hydrazine method. It reacts with all amino acids whose carboxyl group is bound in peptide linkage, creating amino acyl hydroxides. Okay, wait. Hapit na. Okay, so we also have the secondary structure of proteins. Now, again, for primary structure of protein, it looks like this one. Okay. Sama na dapat ha. This one. Okay. So, just like there's an analogy here. Now, all right. Like a telephone, if you have seen a telephone, nasa inani, the cord, now it has the primary structure is just a sequence or is just a straight line, and then you have their secondary structure. The secondary structure has localized folding. Now it can be an alpha helix or a beta plated structure. Okay, just like this one. Okay, so if you have the structure of your protein, a alpha helix, so it's like a DNA, wherein the arrangements of your H bonding are in between, nasa sulod. And also we have your beta pleated sheet. Beta pleated sheet. Okay, so we have the secondary structure. We have two alpha helix and then beta pleated sheet. Okay. All right. Now we have this one. Okay. So the OH, the bonding in an alpha helix is naasa sulod, the OH. Okay, naasa sulod sa helix. Then the R group, okay, the R group are outside, okay, outside the helix, this one. Okay, so the OH are in between, inside the helix, and then the R group are, ano siya, R group is outside the helix. Okay, so that's it. Now, okay, beta plated sheath. So it more siya papel class nga imong i-lukdong. Okay, more para sa inyong by layer. Then we have also the tertiary structure of protein. So there are 4 types of interactions happen here. Now in your secondary, only the OH is only the OH. But here it's the disulfide bond. So the disulfide bond is the SS, the sulfur-sulfur bond that link together. Now link chains together and cause chains to twist and bend. So for your tertiary motion bending, because bending and folding because of the SS bond, the disulfide bond. Now we have also the electrostatic interactions. We have the ionic interaction or salt linkages. Salt bridge charged side chains of acidic and basic amino acids. Okay, so we have this one, the basic, and then your acidic. Now, if that links to bond together, that is by electrostatic interaction. Now, we also have each bonding, just like in your secondary. Your hydrogen bonding, it's between the polar acidic or the basic group. Okay, we have this one. So, the structure. Then we have also the hydrophobic interaction. It's in between the nonpolar and then nonpolar phenylalanine and the leucine nonpolar. Okay, when that forms, it interacts through hydrophobic interactions. So just take note here of the interactions that occurs in tertiary structure. We have the disulfide, the electrostatic, then hydrogen bonding, and then we have the hydrophobic interaction. Okay, now here there's a drill here. So what is the interaction that occurs in letter A? Okay, we have Riname. Letter A. Okay, Jalea.
Ma'am,
Okay, what's the interaction that occurs in letter A?
primary,
It's a tertiary structure. Okay, tertiary structure na siya. Nara sa katong upat. It's a tertiary. Now, the interactions, again, so ito interactions sa tertiary, we have the disulfide, the hydrogen bonding, the hydrophobic, and then we have the electrostatic, the salt. Electrostatic occurs when we have a positive and a negative charge. Okay, so letter A is
Electrostatic, ma'am.
electrostatic
okay, look at this one. Hindi mo klaro. Okay, so we have this one. Letter A is we have the negative. Okay, look for electrostatic interaction. It's between ionic interaction. Ionic, gani class, when we say ionic, it's a charged, it's a charge, it's charged. So we have this one negative and then we have the positive. Now, if that occurs in your tertiary interaction, then that is what we call, what's the interaction in letter A?
symmetric interaction, ma'am.
Electrostatic. Okay, what about letter B? Letter B.
Ma'am, kuan ma'am kanang murag hydrogen bond.
Okay, hydrogen. What about letter C?
Kuan
Electrostatic, ma'am.
electrostatic ma'am.
Okay.
Static.
Then, what about letter D?
Hydrogen bond siya pun ma'am. May mag same structure.
Between the
It's
hydrogen bond,
hydrogen bond.
Hydrophobic ma'am.
Oh, kung hydrophobic, di ba dapat non-polar? Nya, non-polar din eh.
Ay,
Non-polar din eh. Okay.
hydrogen bond ma'am.
Okay, now let's go back. Tanawang hydrophobic
Ah,
interaction. Okay. This one. Okay, look for hydrogen bond. Parehas siya sa hydrogen bond.
Yes, ma'am. Same to. Sa T.
Parehas yan.
Ang
Okay,
kuan
let's
lang
go
siya.
back. All right, so that is okay,
Hydrogen.
hydrogen bond. All right. Okay, so we have this one, the quaternary. Okay, so it's the highest level of protein organization. Now, the structure there, class. Anong mag-change ang structure sa protein? Ngano mo na primary, secondary, tertiary, and the quaternary. Mm, why?
Because of the level of proteins, ma'am.
Level of
Proteins organization.
ay, yeah, so, oh, ngano na ang may inaana? Ngano na ang may ina ng protein organization? Ngano mang mag-organize siya? Kaning primary, secondary, tertiary, and quaternary.
Because of the bonding happen, ma'am.
Ha?
Because of the bonding happen.
Yes, because there's the bonding also. The bonding kay mao man na siya ang maghatag niyang shape. Okay. So the protein ano siya organize, okay, organize itself for it to function effectively. Now it organizes into a shape that it can best store enough energy. Okay, enough energy because uh iya himuon niyang self nga ano siya kanang fulfilled kaayo iya ma-fulfill na iyang work in so mo iyahang i-adjust iyahang shape into the best shape na maka-store og enough energy, okay, enough energy in and also to the best configuration. So in ana siya change iyahang mag-change nga nung naa siya lahi-lahi na structure. So here also oligomer contain even numbers of subunits. So we have that one. Okay, we have a summary here. Okay, so we have that one. The primary structure is just a sequence. It's just a sequence. Then we have the secondary. And now we have an alpha helix or a beta pleated sheath structure or shape. Then we have your tertiary. Okay, tertiary. There are the interactions that occur in tertiary are four. We have disulfide bonds, electrostatic hydrogen bonds, and hydrophobic interaction. Whereas in your secondary structure, the interaction or the bonds there are focused on the hydrogen bonds. Again, the R group in your helix face outside or in the exterior of your helix, nasa gawas. Your OH bonding kay nasa sulod. Now, later, when we go to nucleic acids, we will really understand this one. Okay, because there are proteins in your nucleic acids, in your DNA. Then we also have, okay, now in quaternary, we have three interactions. We have electrostatic, hydrogen, and hydrophobic. Okay. Now almost na. All right, we have that one. Then we talked this already, the alpha keratin. Okay, keratin, it's the protein responsible for the rigidity of your hair, of your nails, and the mga horns of the turtle's shell. Okay. So the bond there is your disulfide bond, the S, the SS bond. Okay. We have that keratin. That's why kana mga shampoo na to are na mga keratin for long elastic hair. Elastic hair. We have this one, fibrous proteins. We have the collagen. Okay, the collagen for the rigidity of your bones and then your teeth. Okay, the ligaments, the blood vessels, and the skin also has protein collagen. That's why kini mga for younger looking skin is nagamit kuanan siya og collagen. But actually collagen is already present in our body naman siya paghapon. It's 30% pagani. Okay. Then we have the myoglobin. Okay, the myoglobin. What's the function of myoglobin? It stores oxygen in your muscles. Okay, it stores oxygen and the shape is this one. Okay, now also here your fibrous proteins are just primary structure, no? Is it primary? It's a secondary structure. It's a nicer helix. Then we have the globular proteins, myoglobin, hemoglobin. Look at the structure. It's quaternary. Okay, then we have the prosthetic groups. We have the glycoproteins. The prosthetic group in glycoprotein is what? Unsa gaya itong prosthetic groups naman na sa atong first? They are conjugated proteins. So the conjugated, it's complex proteins. Now we have two classifications with to. We have the simple proteins and then we have the complex proteins. The simple proteins are ano siya? All amino acids. All amino acids. Now when we say complex proteins, it has aside from amino acid, it has prosthetic group. Prosthetic groups are non-amino acid group. Like this one, we have protein and then we have your monosaccharides, your glycogen monosaccharides. Then we have immunoglobulins. It's still a glycoprotein, so the prosthetic group is a monosaccharide. Then we have the lipoproteins, we have the LDL, and then the HDL. Now, between the two, which is good and bad cholesterol? Kapit na. Okay, which is a good cholesterol? LDL or HDL?
LDL man.
Ma'am. TL, ma'am. Ay.
HDL.
Ah,
Okay, HDL.
okay, ma'am.
Okay, HDL is a good cholesterol. Then whereas your LDL is
But,
less healthy. Okay. Now we have that one. Okay, protein denaturation. When we say protein denaturation, denature is the cleavage. It's the cleavage of the protein. Now, when we cook, denaturation is a good process also because just like any magluto taog meat, the protein when we cook meat, the protein there will be denatured. When we atong lungagon ang itlog, what's the protein in your egg? We have the albumin. Now, if ato na siyang lungagon, then the protein will be denatured. It will be cleaved. So, meaning that I know cooking is helpful because mas dali siya ma-break, mas dali noon siya processing sa imong body kay nag naa na siya initial denaturation, naa na siya initial cleavage. So that's why cooking is ano siya recommended. Then we have this one, okay? Partial or complete disorganization of protein's tertiary structure. Okay, so from this structure, then it denatured, may mo siyang inani. Then cooking food denatures the protein but does not change protein nutritional values. Coagulation, precipitation, or denaturation, egg white, a concentrated solution of protein albumin, forms jelly when heated because the albumin is denatured. When denatured ba, maguba. Okay, this one, oh, nagiguba niya. Okay, giguba. Now, we have that one. Cooking the nature's proteins makes it easy for enzymes in our body to hydrolyze or digest the protein. So, good ang imong cookie when we cook with the nature the protein there. Iguba na nato siya, na siya initial or partial digestion. Then it kills aside from that, it kills microorganisms by the denaturation of proteins. Now, when we have fever, ano, pag init kayo ta, why is fever? Ano man siya? Ang fever is just a result, is a fever, kanang init kayo ta, is a result of the interactions inside your body. So, naay nakasulod dito na outside mga foreign materials, and then your immune system responds to it. Oh, naibagong ano, bacteria. It's new. It's foreign. So, it will, ano siya, iyang ipainit ug ayaw mo painit siya, painit para mo pud na mamatay yung tatong foreign bacteria. So, it's ano, ang imuhang hilanat is a good sign. It means that your body is responding to foreign materials inside the body. Now, however, continuous fever, dugay kayo nga fever, it will cause denaturation of your proteins. Kakatong mga good proteins sa imuha, it will denature. So, that's why nga, inig maghilana ta, moinom din tag kaning pawala sa kainit kay kung magpadayon imong kainit, mag-apil ang imuhang mga proteins, mga enzymes, maguba, ma-denature. Then when that happen, when the structure changes, it will it will have it will respond to different no function na dayon. So then we have this one, the disulfide bridges, okay, the disulfide bond. So again, keratin, the alpha keratin is in your hair. It's the bond there is your SS, the disulfide bond. Okay, the disulfide bond. Now, if you are curly, so there's a disulfide bond there. SS. Now, if you want it to be straight, you have to denature. So, gubon sa nimo imuhang disulfide bond. Gubon nimo ang imuhang disulfide bond. And then, you add a treatment there. Then, after that one, pag ma-okay na, imuha na po dahil ibalik ang imuhang disulfide bond sa imuhang hair para mulahi siya. Okay. So you put a treatment in between of your disulfide bond. So kung curly na ka, gubuon niya tong bonding sa imuhang buhok para Then you add a treatment, then after that one, ibalik niya. Ibalik dayon niya ang disulfide bonds. Okay. Right. Okay. All right, so we are done. Yes. Okay, so that's all for proteins. Okay, don't forget, inato lang. Ano, the bond, what's the bond in your hair? Okay, you have there your disulfide bonds. Okay. So that's it. Your protein is just a condensation reaction of amino acids. When you form a polypeptide, so there it will be a lot of amino acids. So that's all for today, and that's all for proteins. Okay, so question. Sabi, okay, question.
Ma'am kanang unsang oras ang exam ugma ma'am ay quiz.
1 p.m.
Okay,
Ay,
okay ma'am.
kamo. 1 p.m.
Sige po.
Then, pagka Thursday na ay mag-demo. So, nindot to daghan mo class. Kay na ay mag kato atong kuan tong internet to siya mag-class si Thursday.
Kanang ingnon lang
Focus,
namo ma'am.
ha?
Ingnon lang namo sila ma'am.
Mm. Okay. So, that's all for proteins. Again, proteins is is a polypeptide. Then it's from a peptide bond. Okay, we have essential amino acids also, meaning our body needs it because it can't make it. Then we have again the complete protein, and then we have also incomplete protein. Now, para makompleto siya, we will complement. So we have that complementary proteins. Question. For the structure, just take note na ano lang siya for the primary structure, it's just a sequence. Then for secondary structure, it's for na siya beta helix and then a beta pleated sheath, and then we have the helix. So the interactions there are OH bonding. Then we have your tertiary, we have 4 interactions. And then we have your quaternary, there are 3 interactions. Now, proteins changes its organization for it to function effectively. Because again, different conformation, different configuration, has different responses and different functions in your body. We have that one. Okay. Then the primary structure. Okay, again, we also have the simple and the complex proteins. The complex proteins are those, has the presence of amino acid groups or prosthetic groups like glycoproteins, lipoproteins. We have hemoproteins, phosphoproteins. Na siya sa slide na to, class. Then again, the amide bond or the peptide bond there is in trans configuration. Then when you name a peptide, the last amino acid that has the or C terminal end will have the complete name. Other others will have an ending of "il." Then also the isomers, okay, isomers are have the same amino acids but different orders or different sequence. Now, the isomers is equal to the as isomers as amino the length of amino acids increases, isomers also increases. Isomers can be calculated using an n factorial. Then what else? Again, the Zwitterion ion is when the Zwitterion ion is when two ions coexist, when you have the positive and then the negative charge coexist. It's in the pH wherein there is a charge and negative ion present. Then we have again under different pH, there will be different structure of your amino acids. Now under acidic solution, uh, or low pH, NH3 will NH amino group is protonated. Then under basic condition, your COO, your carboxyl group loses protons. Deuterium ion has a net charge of 0. When we calculate the pi is just an average of the two pKa wherein the deuterium ion structure forms. Okay, so what else pa, Jud? Hapit na ta, class. Kuha na pa din ta. Mag-exam sa proteins. Kamu na dayo magkuhan, ha? Okay, amino acids. It contains carbon, hydrogen, nitrogen, oxygen. Okay. So for the lipids exam, just take note of the structures. The good fats, then the bad fats, the structure of sphingolipids, the cerebrosides, gangliosides. Siya. Then also the solubility and then the melting point. Okay. So that's all. Transconfiguration. Okay. So also we have the polar and the non-polar, then the basic and acidic amino acids. Take note also of that. Okay, so that's all. So just a little change of your protein will, I know, will result to a different function. So that's all. for today.
Thank you, ma'am.
Okay, thank you so much. Bye-bye.
Bye, ma'am.
Yung mga
Okay,
test.
so pasabot na pud mo sa mo exam sa proteins.
Okay, okay, ma'am.